Yes, I have the secret formula. Now I can make the best century eggs in the world.
'Interesting riddle. What could it mean? Hmm, I wonder.
That's what it means by three different formulas, three different amounts of diluted NaOH. But what branch of science would I need to study and research to make this century egg?
Whoa! Biochemistry it is then. But wait, how will biochemistry help me make the best century egg in the world?
The egg will change slowly as it reacts to the NaOH. The room turns brown, the sun turns green, so does the white and yolk of the century egg. The mysterious change is known as coagulation, or denaturation. It is the secret to a successful century egg.
Okay, but okay. How does this coagulation denaturation thing work though?
Coagulation is the transformation of a liquid or solid into or as if into a soft, semi-solid or solid mass, usually of a light or protein change. Denaturation is like it. It is a process in which the folding structure of a protein is altered due to exposure to certain chemical or physical factors, causing the protein to become biologically active.
Interesting. Interesting indeed. Now let's start making the century egg.
2 hours later.
But first, we must write down everything about this experiment using the scientific method, just in case the formula gets stolen. Now I wonder, what is the problem or aim of our experiment? How will using different amounts of NaOH concentrations, 400 grams per liter, 300 grams per liter, and 250 grams per liter, in the solution NaOH plus NaCl plus H2O affect the century egg's opacity or opaqueness? Which one works the best? That is our question.
I was inspired to do this experiment because in Taiwan, century egg is the traditional food and the science behind the century egg is quite fascinating to explore. Safety, glasses, mask, glove, covered clothes, pants, and covered shoes. Okay, we're going to start our experiment.
The independent variable is concentration of NaOH. The dependent variable is quality of the egg, measured by observable coagulation and the opacity. The control variables are environment, temperature is egg, opacity sensor, exposed light sensor, airtight bag, etc. That's about it. I'll copy down the method in a moment. It's very long. My experiment is finished. Unfortunately, none of them were successful. It must have been this formula. It must have tricked me. But I have no time to punish this formula right now. I have to go through the data to find what went wrong. Quick, we have no time. My opponents, they will finish their century eggs soon. Let's go. Here's the graph. Over there you can see this is the amount of NaOH in relation to the pH level, and it's weird how the pH rose as the amount of NaOH decreased. Usually, the more NaOH you add, the higher the pH. Here you can see jar 1, jar 2, jar 3. These are the data put into graphs. It shows the coagulation of the eggs. The egg yolk is yellow, albumin, the egg white is red, and unfortunately we didn't get to test opacity, so the opacity is 0. Okay, this chart is the total coagulation chart. You can see over time the coagulation of the yolk went up and the coagulation of the egg white or albumin went down. Blue is jar 1, orange is jar 2, and red is jar 3. So throughout this experiment we have a few problems. You can see that the pH level was inaccurate. Somehow it got higher as the NaOH decreased. So that was unusual. And some theories I have is that perhaps we mixed up the pH and we didn't mix it evenly. So the NaOH was precipitating or sinking to the bottom of the jar. So the 3 jars did not have equal amounts of NaOH, or the same concentration. So here's the figure. NaOH is condensed to the bottom. The top part has less NaOH. I think the main problem, is that the pH level was too low. It was 12.5 the highest, but the suggested pH is actually 12.5 to 13.6. So we missed the bullseye zone. That's why our eggs did not work.
So it seems like this was the wrong formula, and now I have to do more research to find the right one. I don't like researching. 48 days spent.
Guang, do not be sad, but rejoice.
I know I should be happy, but failure is hard to overcome. Right?
Do not worry, you will overcome. Now think about how you can make this a more successful experiment. Perhaps you will be the writer of the 4th formula of the Temple of Wi-Fi. Your mistakes will help you make the right choices this time. Be careful and be safe.
Yes, I should write the 4th formula. This experiment helped the study and coagulation of egg protein, and not just eggs. Coagulation occurs in blood veins as well, as there is protein in blood. It can cause hypertension and other diseases. This experiment also helped us understand more about misfolding protein diseases. Of course, that would need more research, but it could help us understand those diseases, and many other things actually. A lot of medical things about protein can be found through these kind of experiments. Perhaps the experiment wasn't so much of a waste of time after all. And since I made a lot of mistakes during this experiment, I can make sure not to make them next time. I can not add more water to the NaOH solution, so the pH level will be above 12.5 and the egg can be coagulated. Another mistake I made was making the experiment too complicated. Perhaps I can make it more simple with only 2 parts or 3 parts to make it easier to follow as well as less time consuming. Of course, if we have the right pH, it will be less time consuming on our part. And after making all those changes, we would have the 4th formula ready. It will look just like this. Well, see you 1 month later. Or maybe never. Then, bye.